I'm Anil Kumar, and here is a test question for you to sketch a transformed sinusoidal function. Remember, sine and cosine both are considered as sinusoidal functions, right? So the question here is, sketch graph of y equals to 5 over 3 cos of 2x plus 60 degrees plus 1 over 3. You can use the two-step method. In the first step, sketch or incorporate stretches, compressions, and reflections, and in the second step, do the translations. You can pause the video, sketch, and then look into my suggestions. Well, whenever we are given equation like this, the very first step should be rewrite the equation in the correct form. So what I'm trying to say is we'll write this as y equals to 5 over 3 cos of, factor out 2, otherwise you'll make a mistake, 2. And then we have x, when you factor out 2 we get plus 30 degrees plus 1 over 3. So that is how the equation should look like. Now from this equation you know that the axis is 1 over 3. So you can write down the characteristics if you want. So let us write down. So we have amplitude, right? So a value is 5 over 3, that is the amplitude. Y equals to 1 over 3 is the axis, right? So this is the axis. Time period t for us is, it is in degrees, so we'll do 360 degrees divided by this number 2, so it is time period of 180 degrees. And phase shift p is 30 units to left, so we'll write minus 30 degrees. Is that okay? So these are the characteristics of the function. You can also get maximum and minimum. So you could write maximum value will be 5 over 3 plus 1 over 3, which is 6 over 3 or 2, and the minimum value will be equals to, you should do 1 over 3 minus 5 over 3, so that is minus 4 over 3. So that is your minimum value. Now in the first step we will incorporate stretches and compressions. So the stretches and compressions means that we have an amplitude of 5 over 3 and time period is 180 degrees. So these are the two things which we'll incorporate in the first step, correct? We need to take a proper scale also. 1 over 3, 5 over 3 are all fractions. So let us say this is 1 over 3 for us, right? So let us say this is 1 over 3. Let me write down here 1 over 3. So that will be minus 1 over 3. Okay. Now with that scale, we will define or sketch a cosine function. Cosine function, as you know, starts with the maximum, right? So we'll go for the maximum first, which is 2 units. So we'll go like this. 1 over 3 is the axis. We are going up by 5 over 3. So over 1 over 3, the each division is 1/3, 1/3, 2/3, 3/3, 4/3, 5/3. So that is what it is, correct? So even otherwise, you can check that that means 1/3, 2/3, 3/3 means that is 1 for us, correct? So this is 1 for us. Each division is divided into 3 equal parts, and this is 2. And as we calculated, maximum value is 2. So these are all checkpoints for us, correct? So that becomes the vertical scale for us, right? Now on the horizontal scale, we want 180 degrees. So we could go by 30, 60. So let's have 2 division as 30. So 30, 60, 90, right? So this becomes 90 for us. So 90 degrees. And then again 30, 60, 90. So that becomes 180 degrees, correct? So we have 180 degrees as our time period. Now this time period should be actually divided into 4 equal parts. You get the idea, right? It should be always divided into 4 equal parts. Now, so we have 2 parts. Now 1, 2, 3, 4, 5, 6. So that is the middle value. Is that okay? That is the middle value. And on this side also we have a middle value here. Is that okay? Right. So we have divided the time period into 4 equal parts. Let me sketch some lines here just to show you what are the 4 equal parts. That is for 90, correct? You don't have to sketch these lines. It is only for me to explain you, right? Since we use 30, 60, 90, half of 90 is 45. You get the point? So that is why I'm just showing you that these are my 4 equal parts, which kind of define our quadrants, right? So what we do is that every sinusoidal function, the time period is divided into 4 equal parts. Now the cosine function, starts with the maximum. Minimum value in this particular case is from 1 over 3 will go down 5 over 3. So 1, 2, 3, 4, 5. So that is the minimum value. So what I do is this is my guidelines. There we have somewhere minimum value. Is it okay? Now let us sketch the 5 points. In this particular case, let us first sketch with only stretches, compressions and reflections. Stretches 5 over 3, so the amplitude is 5 over 3. So 1, 2, 3, 4, 5. So that becomes the first point. Let me use a different ink. 1, 2, 3, 4, 5. So that becomes the first point. And then we know it will be 0. So at the second quarter it is 0. And then in the third quarter it has to be a minimum. So 1, 2, 3, 4, 5. That is the minimum value. And then again a 0. And then a maximum, which is 5 over 3. Connecting these with a function which looks like a cosine function will give us the first graph, which is, we can write this equation as 5 over 3 cos of 2x. So we have incorporated both vertical stretch and horizontal compression to sketch our first graph. Now in the second graph, what we are going to do is we are going to incorporate translations. So we have 2 translations here. One is vertical translation by 1 over 3 and the other one is horizontal translation of 30 degrees to left, right? Now 30 degrees for us is 2 units. Do you see that? And 1 over 3 is 1 unit on the vertical side. So we have to move 1 unit up, 2 units down, which is 30 degrees. Okay. So every point will use 1 unit up, 2 down, 2 left. So that is your final point for the first point. So we have these 5 points which we are going to translate. So 1 unit up, 2 left. So that is the second point, correct? 1 unit up, 2 left, third point. Fourth point, 1 unit up, 2 left. Fifth point, 1 unit up, 2 left. So we get the fifth point. Connect these to get your final graph, right? So we have, let's connect them. So that is the cosine function, which is y equals to 5 over 3. You can write 2x, doesn't matter, 2x plus 60 degrees plus 1 over 3. So that is the final graph. So likewise, in 2 steps, you can actually sketch the function. Now it is time to test whether this function is correctly sketched or not. The axis is 1 over 3. Let us check these points. Are they at 1 over 3? Yes, they are. Do you see that? So that is y equals to 1 over 3, right? Is the maximum value at 2? Yes, it is. Do you see? It is at 2. Is the minimum value at minus 4 over 3? This is the final graph. Okay, so that is correct. 1, 2, 3, 4. So that is minus 4 over 3. I was counting that one. So minus 4 over 3 is the minimum value. That is absolutely correct. So you can check that your graph is perfectly fine. So using these 2 methods and the way I'm telling you, it helps to get an idea of how the graph should look like and how to check whether it is right or wrong. I hope that helps. Thank you and all the best.